stop me if it seems that I'm going too fast. Okay. Point to this. No? Okay, cool. Yeah, so I'm Kashif. I work at Imply. Imply is a real-time analytics company, and we basically build and maintain Druid. And we help you extract the maximum value out of Druid through our SaaS offerings and our cloud hybrid offerings. I'm also a PMC member at Apache Druid, but I only recently came into that title, so please don't judge me if I make any mistakes. The agenda is that I intend to talk about some Druid internals with particular focus on the master node. And we'll try to understand what are the scalability concerns with Druid as of today, and what we can do to mitigate those. So to kick things off, let's just look at this basic architecture diagram. I think Shiv and his companion actually showed a better diagram, which talked a little more about the inter-process communication. This one does as well, but it probably doesn't do justice to the master node. And since that's what we are here to talk about, I drew something up, right? Now, what's the first thing that comes to your mind when you look at this? Anyone? Anything from a distributed systems point of view? Like special focus on the thing in the center. Exactly, yeah. So that's essentially, it has the liability of becoming a single point of failure, right? But you would say that, okay, distributed systems, this is not a unique problem. It's common to all distributed systems with a very simple remedy, right? You just make it highly available. One master node goes down, the other one takes over. But the problem is that in such an architecture where all the services talk to a single central node, fault tolerance is not your only concern. Your concern is also bottlenecks, right? Because all the information, all the metadata that exists in the system has to flow through your central master node, right? And as Shiv pointed out, it is not horizontally scalable, right? Which is to say that you can only always have a single master node, right? We can't have distributed masters, multiple masters doing their own thing, because then we would have something of a split brain issue, right? I suppose most of you have worked on distributed systems, you would be very familiar with the split brain issue, right? So since all of the information has to flow through the master node has to be able to hold that information, process that information, and do this at high concurrency, because all of the services want to get quick responses for whatever task that they're doing. So you can see that if for any reason the master node gets blocked up, all of the communication ceases. And not just that, your entire chain of communication all the way to the metadata store is broken itself, right? So basically the cluster just halts. Nothing else is going to make progress. And if you have used Druid versions prior to the latest one, 27, if you used any version prior to that, you might have run into issues where the master node just doesn't do anything. There are no logs, no metrics, no error messages. You absolutely don't know what's going on, right? So in that case, you start turning knobs randomly, and that just makes things even worse, and we'll talk about that. So to identify the bottlenecks, let's try to put them into buckets, right? Let's try to break down the problem into simpler pieces so that we understand exactly what we are dealing with, right? So I have tried to categorize this into 3 primary concerns. As I said, you have to be able to hold all the metadata. You have to be able to process all the metadata at high performance. And you have to be able to do this at high concurrency, right? Now, I've also named some of the knobs. I hope all of this is clearly visible at the back, even the bottom stuff. Cool. So I've mentioned some knobs, right? Things which you can do to alleviate your problem of scalability, right? And but the thing is that all of that requires vertical scaling. Note that I say vertical scaling, not horizontal scaling. And vertical scaling means using a bigger machine, right? So if you use a bigger machine, obviously you get more memory, you get more processors, and thus more threads. But that's essentially just kicking the can down the road, right? You've not really solved the problem. You still have the problem. And the other problem is that vertical scaling does not come cheap. Hence the existence of distributed systems in the first place, right? If vertical scaling was cheap, we wouldn't need distributed systems. So this is essentially what we are trying to solve. For the time being, I'm going to skip the size part, the size aspect of it. What we are going to talk about is things we control immediately, right? which is the code itself, right? The performance of the code and the level of concurrency control in the code, things which we as developers know how to tweak. As it turns out, give me a moment. As it turns out, the two remaining concerns that I had listed over here, speed and latency, which is more about concurrency, they happen to map almost neatly to these two services that the previous session was talking about, coordinator and the overlord. Overlord is something which lords over all of the ingestion which is happening. So all of the data which is making its way into the Druid system is monitored and managed by the overlord. But once data has landed into Druid and it's neatly packaged into something called segments, then it's all the responsibility of the coordinator from there on, right? All the way until you decide to finally permanently delete the data. That final permanent deletion is the kill task that was the question that was asked at the back, right? That's that final step is again taken care of by the overlord, right? Now, as it happens, coordinator is something which needs to be able to perform at speed, and overlord is something which needs to be able to perform at high concurrency, right? Because overlord is talking to a bunch of different services. Can anyone say why? Why overlord has to be highly concurrent? Any guesses? Could you? Sorry. Yeah, exactly. It talks to the middle manager. It talks to all the.
So it has a lot of middle manager processes, PNs. It has to coordinate among them.
Exactly.
And, there are parallel PNs which runs across the batches.
Yeah.
So that's the process.
So the overlord has to talk to a bunch of processes, right? The larger the amount of ingestion that you're doing into the system, the more burden you are putting on your overlord. The more tasks that you have in your system, task is nothing but a unit of work for ingesting data. The more burden you are putting on the overlord, and the more data that you have, like eventual data which is finally ingested, the more burden you are going to put on the coordinator, right? So let's just try to dissect each of them separately and see exactly what's going on. The coordinator, as it turns out, is essentially just an execution pipeline. There are a bunch of duties that you're supposed to run one by one in a periodic fashion. And all this is meant to do is, again, since I'm thankful for the previous session because it was a very nice precursor. They lay the foundation of a lot of things that I'm talking about. So yeah, it essentially just decides which piece of data, which segment is supposed to live on which server. That's pretty much the entirety of the responsibility of the coordinator, which you can see here, right? But we'll get to this in a moment. The other stuff that you see, which is talking to some external processes, right? These are other duties that as the coordinator grew, as Druid evolved, we tagged on more duties onto the coordinator so that, these things to augment the functionality of the coordinator or to piggyback on the infrastructure that we already had in the coordinator, right? But as it turns out, these have external dependencies. Now, any of these black boxes, the data server or the meta store or the overlord, they can get stuck for their own rhyme or reason, right? Now, if they get stuck, they might cause the respective duty to get stuck. And the problem is that if any of these get stuck, the entire pipeline is blocked. And if the coordinator is blocked, nothing else happens. Nothing works, right? Your cluster basically ceases to work. You don't get any metrics. You don't know what's going on. You start doing things at random. And then the final remedy. Does anyone know what's the final remedy? Restart, right? There's nothing else you can do. So you restart. So what we did is you take out all of these duties which have external dependencies and just move them from the critical pipeline. Keep the critical pipeline the only essential stuff that you want to talk about, that you really want to work on, right? So this is the essential segment loading pipeline. This has always been the critical path of the coordinator, right? And what's happening here? It's nothing but decisions are being made to assign segments, pieces of data to respective servers. Now, it has to be done in a strategic manner, right? Because you can't just place data randomly, right? Otherwise, it would be very simple. Why can't you place data randomly? Because you have to optimize it for your queries. And that's pretty much the whole thing that Druid is known for, right? It's nice storage format and it's optimal placement of data. That's why the queries are fast. So if you screw that up, your queries are not going to be fast and you won't even have Druid. So since it has to be strategic, it consults something called a balancing strategy, right? Which is nothing but a complicated algorithm, which does some kind of integrations based on exponential functions and all that. And it's very compute intensive, right? So as it turns out, this in truth is the rate determining step of the coordinator. So you saw we started off from the entire Druid cluster, and through the process of elimination, we have been able to spot the exact place where we need to put in some effort to finally raise the bar of our scalability. And as you can see, can everyone see the complexity? It's big O of nk, right? So as the number of segments in your cluster increases, this complexity is going to increase. The time this takes is going to increase. The only hope you have of controlling this is limiting that number k, right? Where k is the number of decisions that you take in each cycle. Let me just take a moment here. So for this to sink in. So it's big of nk, n is the number of segments that we have in the cluster, and k is the number of decisions that we make, right? And traditionally, this is what we have done, right? We have tried to limit that k by imposing various configs on the coordinator. Okay, I'll just give you a moment to read through these. So as you can see, there's a common theme here. All of these configs are telling the coordinator to not do too much of something, otherwise something bad will happen, right? So if you see this, do not do something, otherwise something will happen. Do not do something, otherwise something will happen, right? It's trying to limit the amount of work that the coordinator does. And why is that? Because it's trying to limit the value of this k, right? So if you kind of force this value of k to be a constant, this whole complexity becomes linear, right? Rather than tending to n square, it becomes n. But there's a problem. Do you see the amount of configs we have added? Like these are just 4 and 3 more, like 7, 8 of these configs that I've written over here. And they are fairly complicated and difficult knobs to turn. I don't know if you ever had to change the values of these configs. It's fairly difficult to understand and very difficult to reason about. Like, look at this config. What does it even mean? Such a long name for a single config, right? And turns out it's not even that important. Okay, so that's the thing. Like with configs, it's always a double-edged sword, and it is a necessary evil, but it is always a double-edged sword. Which is why while adding configs, you have to be exceptionally careful, and you must always remember the other cap theorem, which applies to configs, right? So okay, tough crowd. Cool. The theme is that the coordinator is trying to avoid overcommitment, right? The coordinator is trying to ensure that it doesn't do too much of something. Now let's try to understand why. Through the configs, it's doing all of that. But let's for a moment assume that somehow we are able to figure out the problem of the balancing strategy. What else can go wrong, right? And the two things which come out is that all the decisions that the coordinator takes, they cannot be taken back, okay? So if you commit too many things, commit to doing too many things, you say you assign too many segments to different servers. Right off the bat, let's say you say, okay, this server has to load 10,000 segments. The other server has to load 10,000 segments, right? So which means that you have made a lot of decisions. But while these decisions are taking place, they are going to completion, the state of the cluster has already changed, right? So the decisions that you took were based on a stale snapshot of the cluster, right? So, and now you're stuck with whatever decisions you made because you can't go back. The other problem is that if you take a bunch of decisions, all these decisions start competing with each other, right? And balancing might start affecting replication. Replication might start affecting availability, right? So how do you deal with all of this? And let's just take a moment here to just understand these problems, because this problem definition is all it takes to get to the solution. And the solution is so simple, it's almost silly. Question is, assignments compete with each other. The answer is why? They shouldn't. Just define a clear priority. Decisions cannot be taken back. Why? It's your system. Make sure you can take back decisions, right? So just prioritize and reflect. So in Druid, like in life, all the decisions that we take, we must prioritize amongst them. And all the things that we do, we must reflect upon them. That, okay, did I do the right thing, or should I reevaluate or revisit the things that I did? And once you define a very clear priority, that availability is always more important than replication, because if you don't have your data available, your queries are not going to work. So why even care about performance? It just won't work. Now, replication should be more important than balancing. Again, similar principles. Decisions should be taken back if an assignment or a decision that you took is not relevant anymore. It should just be canceled. So this concept, although it's exceptionally simple, right? It's deceptively simple rather, that you just have to prioritize the things that you do and you have to be able to cancel the things that you do. This single vision allowed us to completely revamp the entire coordinator, such that today, through simulations and all of these different improvements that were a part of this project, we have been able to test out clusters, test clusters as well as simulations with more than a million, 2 million, 3 million, any number of segments that you can imagine, right? So at this point, coordinator is not going to be your rate determining step anymore, right? All of this comes in Druid 27 under the smart segment loading mode of the coordinator, which is enabled by default, because as someone at Imply said, we should not allow users to shoot themselves in the foot, right? Even if you have horrible configs, Druid is going to take care of them for you. You don't have to worry about anything. So yeah, I'll take a moment here. If there's any quick question, I'll take that. Otherwise, we'll move on to the Overlord. All right, cool. What happened? Yeah, I'm pressing next. Yeah. Can we do the slide from there? Come. Hmm. Okay.
As usual, we have technical difficulties. In the meantime, there is tea in the back, so please help yourself.
Hello. Yeah, and we're back. I think the sort of this thing is working again. We can start now. Kashif, how much do we have left? Couple more slides. Okay. 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 Let's start. Can we get back? Or in the meantime, if there are any questions, very quickly we can take one or two.
Hi, can you clarify unlimited queue? There was this thing called round robin, but that I understand prioritization wise. But what does unlimited? What do you mean by unlimited queue? Can you clarify that?
Yeah, let me just go back to that slide. Yeah, so you understand the round robin part, right? So that's basically since we realized that initial segment assignments, go back. Yeah, yeah. Oh, yeah, so since availability and replication have to be prioritized, we decided that, okay, we might as well do round robin assignment. The first assignment need not be based on the strategy. So you can do round robin assignments. But the thing is that you still want balancing to take place, right? Because you don't want everything to be round robin and then eventually have to move everything back as governed by the balancing strategy. So you put everything in the queue, and so that the coordinator now knows what is the projected state. So let's say you have 100,000 segments in your cluster. In the first run itself, the coordinator is going to assign everything to all the servers. And let's say there are 10 servers, each of them gets 10,000. But they are not optimally placed. So in subsequent runs, while these load queue is being processed, in subsequent runs, the balancing strategy will move stuff around in the queue itself. So for this purpose, you have to have unlimited load queue, because things we do balancing before load has even finished. Traditionally, we used to do balancing after load had finished, but now we don't even do the unnecessary load. Let it be in the load queue. And since we have the capability of prioritization and cancellation, you can just move stuff around from this queue to that queue. That's why the queue has to be unlimited. Okay. Not loud? Okay. Okay. This okay? Okay. Cool. I think most people are back. So could you go to the next slide, please? Next. Yeah. So we talked a bit about the coordinator, and we spotted the problem, and we came up with a fairly simple solution to all of those problems. Now let's talk a little about the Overlord. So this is, again, this goes back to the initial diagram, the butterfly or the dragonfly thing that I had shown, that the master node talks to all the services. So it's actually the Overlord which talks to all of these ingestion processes. And as we had pointed out, it has to be able to perform at high concurrency because it's talking to all of these services, with the exception of historical and broker, because these are involved only in query. So the coordinator might talk to this, but the Overlord is not going to talk to these processes. So yeah, as you can imagine, all of the information, all the task-related metadata is going to flow through the Overlord, and it has to be able to perform at high concurrency. Next slide. So these are a bunch of things that we did on the Overlord. There is a common theme here, but probably not as coherent as the stuff that we did for the coordinator, because there it was a single problem that we were trying to solve. And here it's a bunch of different problems, a bunch of different attack vectors that we are trying to figure out. So the common theme is that offload as much work as you can from the Overlord to other stuff. Move it from the main critical path so that the Overlord continues to function normally and it doesn't block any processing. So yeah, a bunch of things. Like each of these items are fairly complicated in and of themselves, and they can each be a separate session. But yeah, I've just written down a couple of points to tell you exactly what's going on. So for instance, batch segment allocation is going to help you batch the actions of streaming ingest tasks. So let's say you have a bunch of streaming ingestion going on, and all of these different tasks are trying to add data to different segments, right? So what Druid typically does is when you're adding all of these row information to segments, you have to be able to give an ID to those segments, right? And that ID corresponds to the interval in which you're ingesting the data, right? So all of this can happen in a batch fashion. So yeah, optimizations along those lines. Next slide. This is one of the simpler ones, and I'll just give you an idea of what we did here. And this was a real pain because you might have used the web console in Druid, and where we hit the get tasks API. So what that does is goes and hits the metadata store, fetches all the tasks in the metadata store, tries to load them in memory just because it wanted to access 2 fields, right? So it gets the payload, the blob, JSON blob from the metadata store, deserializes it, then extracts just 2 fields out of it. So we realized that these might as well be top level fields. And by simply putting those fields in 2 different columns, you have now alleviated the problem of your pressure. Okay, yeah, and So this is one of the typical problems that we did on the Overlord, and that gives you a basic idea of the kind of stuff that is going on. There's a lot of concurrency work which is supposed to happen on the Overlord. I think it will be discussed in the next slide. Next slide. No, go back. Yeah, this one. So yeah, so this is the kind of work that is planned, which is already in progress. Like we are trying to improve the level of concurrency control in task queue and task runner, which is again core modules of the Overlord itself. We are trying to revamp the segment loader again for better concurrency. And we did something on the Overlord on the coordinator called coordinator simulations, right? Which helped us establish a functional correctness baseline as well as a performance baseline before we started off with all of this huge refactor. Because in a project of this magnitude, you need to be able to have a very high degree of confidence with all the changes that you're making. So simulations come in very handy. And we are trying to do something similar with Overlord as well. On the right-hand side is a wish list of things that we want to do, but they're not in the roadmap right now. But yeah, these will help scalability even further, right? Now, just to give you an idea of what's going on and the changes that have happened, let's say you're running a cluster with about 1 million segments. So the level of coordinator activity before these changes would have looked something like this in the next slide. And now it looks something like this. So that's what we have. Next slide, please. Cool, yeah. Reach out to me on GitHub, LinkedIn, Slack. That's pretty much all the information I had. There's my handle. And next slide. Yeah, there's some more information we'd like to share. So there is the Druid Summit coming up. And if any of you are interested in presenting a session, just submit your entries by September 25. And yeah, that's all I had. And yeah, if any of you are interested in solving problems which are again deceptively simple like this one, so there are folks from Imply, just talk to them, and yeah, they'll set you right up. Cool, thank you. If there's any question, I'll take that now. No? Yeah. No, I don't think there is. As far as I know, I don't think there is anything in the works right now. No, chances are like, so we work on the Druid core engine itself. Connectors are typically something that as the need arises, people in the community themselves contribute. And like Druid's focus is always going to be to bring data into Druid. Or at the most, maybe data lives in a deep storage or something somewhere. Druid doesn't load it into the system, but is still able to query them. Druid pushing out data to other systems is more of a reporting or something like that. So no, Druid is not going to do that in the near future, at least as far as I know.
Yeah, there have been requests like that. BigQuery, I suppose it needs the data in its own storage, but there are tools like Trino, which can operate on external data, and Spark as well. So there is some initiatives going on that allows data within Druid to be read by tools like Spark or Trino. So once that's available, at least 50% of such use cases will be unblocked. It wouldn't still solve this problem where you do want to import the data from Druid into BigQuery. Honestly, that's something I have not seen that much asked. I've usually seen this other way around, where you want BigQuery and you want to import the data directly into Druid. And I've seen asked where people want to read the data within Druid using something like Spark or Trino. So I guess if some work happens, it will be on those front. Unlikely that there'll be some work happening for the specific ask you have.
Cool. Anything else?
Since the new format of JSON has been implemented,
yeah,
which basically intelligently understands the nested JSONs as well.
Yeah.
But that limits the memory, because if, for example, like I was just trying to query, if the number of input segments are increasing, like the data is increasing within an array.
Okay. No, sorry. Yeah, go on.
So it's a nested JSON data,
Okay.
and because we have the option to apply the JSON schema on top of that,
Okay.
it reads the data intelligently, and it is able to classify that into like array of data.
Right. Yeah. It can identify all the
right.
columns and everything. Yeah.
So, but that is leading to kind of out of memory. If the input is getting higher,
Yeah.
that leads to out of memory, and the task fails, and it keeps on failing
Yeah.
because till the from Kafka we remove it.
Yeah.
So second option was flattening the data.
Right.
So once we flatten that data, it is still working fine. But the issue with that is if there is any new dimensions that get added into that nested JSON, that is not able to parse. So we have to like go back on into the ingestion spec and add more like flatten the columns. Then we'll see the new columns which will be pushed.
Right.
So how do we manage between these two?
Right. So as far as the, and Abhishek can correct me if I'm wrong, as far as the out of memory concern goes, JSON is fairly a new feature, like the auto discovery of the schema and all of those things. They are still in the works, and there are definitely a bunch of things that need to be ironed out. But yeah, as you said, that's the whole point of the JSON auto discovery schema, right? That you don't have to update the ingestion spec. All of that happens automatically. We'll get there eventually. Abhishek can add something if I'm missing.
So actually, just a few days ago, there is a change merged. So what will happen with that change is that during ingestion, when we are merging these nested data, we will not be doing that in memory. We will be writing it to the disk, and we will be memory mapping the data on the disk and merge it. So that would sort of reduce the heap usage and help with these kind of situations that you are describing. So it's going to be in Druid 28, which is sometime in first week of November. So it was merged like few days ago itself.
That answers your question? Okay. Anything else? No? Okay. Thank you. Okay. We get a mic there.
Hello. So if I understand correctly, Druid does its own checkpointing when it gets the data from Kafka, right? What's the reason behind it? Why we are not using Kafka's native offset commit feature?
Oh, that's for exactly once that we do that, right?
Yeah.
Yeah.
So
to ensure exactly once.
yeah, correct.
That's why we commit the offset ourselves, because where you persist the segments, you want the offsets to be persisted in the same place.
Okay.
Yeah.
I think you are probably thinking Kafka also supports exactly once, but it supports exactly once when the input and output is Kafka. So is Kafka. So Kafka streams support exactly once, but if you look at Kafka Connect doesn't support exactly once. It depends on the kind of connector you have. So in Druid, when we want to support exactly once, it's not just the offset. Like we are writing data to deep storage. So all of that has to work in sync. So when there are more than two systems involved, the transactions doing that exactly once becomes much more difficult. So what we have done is like we are going to maintain that offset, and we are going to ensure that when we like recover from that offset, we are going to seek to the Kafka. We are going to take care of the data that may be in deep storage. So that alone is not able, we can't do that just by relying on Kafka. I know there is some KIP as well in Kafka to sort of solve exactly this problem. Ever since Confluent acquired Flink, they are working on, and Flink is going to be the first of application. So maybe then, but still, since it's going to be a major redesign, I don't think we'll actually consider it. But that's the motivation.
I have a question. Why Druid only supports S3 as the deep storage? And are there
Doesn't. It supports all other deep storages as well. There are connectors for those. There are extensions for those.
So can we use any data warehouse to store our
You can use
segments?
any object storage, yeah.
Okay.
Yeah. And like if you feel like I think that was the question, like BigQuery or something, like dumping data from Druid into BigQuery. But the thing is that you're not really exporting data, right? You are still storing data in Druid's internal format, like the segment format. But the question is, where are you putting it? If you want, you might as well put it on your local disk. You can put it on S3. You can put it on GCS, HDFS. anything.
Next question. The reading of the data, while we're doing an index parallel job, we read it from S3. Can we read it from some other data warehouse like
No, index parallel
Snowflake?
job is, sorry.
Snowflake has a data warehouse associated with it. Can
Right.
we read it directly from Snowflake? Because we have multiple data warehouses and
Okay.
the entire org,
Uh-huh.
I mean, I'm not supposed to say it. So we supposedly store our data in a warehouse.
Okay.
And currently foundation is we are supposed to keep our data in two places, one in S3,
Okay.
one in the data warehouse, which costs us a lot. To be precise, $8,000 a day,
Okay.
which is too huge to
Okay.
just ingest the data via S3 because we have the same copy of data in the warehouse.
Okay. So you have your data in Snowflake and actually it's on S3 is what you're saying?
Yes, but Snowflake's S3 is a separate S3
Right.
than this S3 because Snowflake keeps it into
Okay,
a separate bucket
okay,
because this can't be your org
Right,
bucket.
right. So from Snowflake, you put it on S3 and then from S3, you bring it into Druid?
From our S3, we put into a landing zone of the Snowflake, then Snowflake keeps it into own their S3 bucket. But
Okay.
since Druid can't ingest from Snowflake's
Right,
thing,
right.
we are bound to have two copies of the data.
Right. So you basically have a bunch of hops right now.
Yeah.
I think there has a lot of work that has happened along those lines recently. And I think I alluded to that point that we might in the future have cases where data is lying somewhere else. Data is not even in the Druid system. And you're still able to run Druid queries on top of that data, right? We are moving in that direction. We have something called a multi-stage query engine right now,
Yeah.
which allows you to do shuffle-based queries, shuffle-based joins, and all of those things.
Okay, I have a third question. The monitoring is not good enough.
Okay. Yeah.
That's
not a question.
So why? Because we don't know when the historicals, what do you call it, segment cache storage is filled.
Okay. Yeah, I agree.
The zookeeper keeps on dying and
Yes.
we don't get any notifications.
Yes. Yeah. I completely agree with all the concerns that you have about monitoring, error messaging. All of that needs to improve. We are working on that. And as I said, like even the whole thing that we talked about master node going completely dark, not even reporting any metrics, any error messages or anything of the sort, right? So you don't even know what you're flying blind. So yes, all of that is in the roadmap. We want to fix those problems. We know that.
And there is another problem.
Yeah.
It's very difficult to ship Druid logs to either Sumo Logic or to Grafana Loki. It's too difficult to
Druid
raise
logs?
Druid logs. I
Okay.
mean, the machine logs. I mean, there's no such available connector directly to ship the logs. There's no documentation, first of all. And
Okay.
secondly, if we try, they are multi-line logs, which itself is a very big problem, I guess, in Sumo Logic as well as in the Grafana Loki. Have you
mean,
ever tried
the
such a thing?
documentation might be lacking. That's possible, but I know of people production clusters that are using Datadog, and all of it works perfectly fine. They push their logs to Datadog, and you get Datadog's entire search capability and everything. So yeah, probably the
We
documentation
tried
is
with
lacking.
Loki.
Yeah, please
Didn't
do.
work out.
Please do. Yeah, and yeah, if you continue to run into issues, are you on the Druid Slack channel? So yeah, please, all of you, if you're interested, please join the Druid Slack channel. And the community is very active. People respond very quickly. So just ask your questions there. Development related. If you have an issue, you want to create a PR. I think we'll. Oh, thank you. Yeah.
So one other thing about that log migration is that usually it's not possible to have a one-to-one, native integration with every other system. So that log migration, I consider that as an infra issue. So Druid, you are running on Kubernetes, for example. So there it becomes a problem. Okay, I have some containers on Kubernetes. How do I get the logs for those containers to whatever system I want it shipped to? So it really depends on like how you're running Druid, and that will determine like how do you want to ship the logs, as opposed to having, say, some native integration within Druid. Because in the end, it's a database. Like once you start running database somewhere, then it's like either you're using some Ansible, you're using Kubernetes, Nomad. It becomes that infra components problem is like, how do I get the logs from that infra to the system I want? So it's like that maybe that's the place where you should be looking at.